Hello, ladies and gentlemen. It's Matafaro here again, and welcome back to my space. In this video, we shall continue our exploration of the integration world, and in particular, we shall try to evaluate the integral of the fourth root of tan x. It's going to be a long video, so prepare mentally because it packs a whole lot of different parts of mathematics. Use substitution, partial fractions, trig identities, and different sorts of algebraic manipulations. Without wasting further time, let's get right into it. So before going into the actual integration, let's look at some important facts that we are going to need along the way. So first and foremost, we ought to know that x squared plus y squared, the sum of two squares is the same thing as x plus y all squared minus 2xy. So it's a very important fact that we are going to use. Also, how do we decompose the fraction 1 over x minus a, or 1 over x squared minus y squared, into partial fractions? So this is the same thing as 1 over x minus y, x plus y, which is the same thing as a over x minus y plus b over x plus y. And using the cover-up method, okay, so let's say a x plus y plus b x minus y equivalent to 1. So if we put x equal to y, then we get 1 is equal to a times 2y, which means a is equal to 1 over 2y. And if we put x is equals to negative y, we have a is equal to negative b of 2y, which implies that b is equal to negative 1 over 2y. That tells us that 1 over x minus y, x plus y, or x squared minus y squared, is equal to 1 over 2y into bracket 1 over x minus y minus 1 over x plus y. Another vital identity that we're going to need. So I'm doing this now so that I don't have to do it along the line of the solution. Which one do I need again? All right, so we also need to remember that the integral of 1 over x squared plus a squared dx is equal to 1 over a tan inverse of x over a. So I think these are the basic facts that we need. If we come across any other one, then we would have to simplify and explain what it is. So we can now get right into the main form. So how do we integrate the fourth root of tan x with respect to x? So just like any other roots of tan x, to integrate this, the first thing we do is to make a substitution. So let's start with, so let u be equal to the fourth root of tan x. And this immediately implies that u to the power of 4 is equal to tan x. And that implies that if we differentiate both sides, 4u du is equal to sec squared x dx. Oh, one more information I forgot to put is the fact that from the Pythagorean identity, we know that sec squared x is equal to 1 plus tan squared x. Okay, so let's continue. So this means that 4u cubed du is equal to 1 plus tan squared x dx. And since tan x is equal to u to the power of 4, it means 4u cubed du is equal to 1 plus u to the power of 4 to the power of 2 dx. So it implies that dx is equal to 4u cubed over 1 plus u to the power of 8 du. So if we name our integral as I, writing it, we get I equals to the integral of u, since we've said this is u, times dx, which is now 4u cubed over 1 plus u to the power of 8 du. We have not done anything special yet. So this is the same thing as the integral of 4u to the power of 4 over 1 plus u to the power of 8 du. This is just standard u substitution procedure. Now this is where the clever algebraic manipulation tricks come in. So how do we manipulate this integrand? So if it were to be a lower power of u in the denominator, like u to the power of 6, or u to the power of 3, u to the power of 4, well, the best thing would be to try to decompose that into partial fractions by brute force. But let's see if we could use some clever manipulations to make it even easier here. So the first thing I'm going to do is to divide both numerator and denominator by z to the power of 4, or u to the power of 4 in this case. So divide both numerator and denominator by u to the power of 4. That means I becomes 4 over u to the power of 4 plus 1 over u to the power of 4 du. And this is the same thing as the integral of 4 over u squared plus 1 over u squared du. So when you look at that denominator, you see that it's a sum of two squares. And from our facts here, the sum of 2 square, x squared plus y squared, is x plus y all squared minus 2xy. So if we use the same thing here, we're going to get the integral of 4 over u squared plus 1 over u squared minus 2 times u squared times 1 over u squared. So this is our a and this is our b. So a plus b, a squared plus b squared is a plus b all squared minus 2ab. So this is the u. So that means our I has now transformed into 4 over u squared plus 1 over u squared minus 2. But of course, you know that 2, okay, maybe I should keep that and write it in the next step. You know that 2 is the same thing as square root of 2 squared. So we can write square root of 2 squared. Why have I written it this way? It is for us to see this is a difference of 2 squares. So I can actually write that as the integral of 4 over u squared plus 1 over u squared minus square root of 2, then u squared plus 1 over u squared plus square root of 2. So you recall, maybe you already know that x squared minus y squared is equal to x minus y, x plus y. That is the fact that I've used there. Du. Now, well, I didn't have to write it this way for us to have seen that we could use one of the facts that I wrote up here, that we did up here. So when we have the partial fraction 1 or of any difference of 2 squared, x squared minus a squared, or x squared minus y squared, it is always going to end up as, maybe I should copy this, copy and post it here. So this is our x, this is our x minus y, x plus y. So it means that this is going to result into 1 over 2 root 2, because that is 1 over 2y, then into bracket 1 over u squared plus 1 over u squared minus root 2 minus 1 over u squared plus 1 over u squared plus root 2 du. So what have I done? I've only applied these results instead of having to decompose it all over again. So that is the usefulness of what we did earlier on. So x is our u squared plus 1 over u squared, and our y in this case is square root of 2. Beautiful. So since we've gotten that, we can actually pull out the 1 over root 2. So this will be equal to 2 over root 2 integral of 1 over u squared plus 1 over u squared minus root 2 minus 1 over u squared plus 1 over u squared plus root 2 du. Okay. We have to be clever from here. We have to be smart. And 2 over root 2 is just equal to root 2. So I can rewrite that and break this down into 2 integrals. So this is equal to square root of 2 times the integral of 1 over u squared plus 1 over u squared minus root 2 du minus the integral of 1 over u squared plus 1 over u squared plus square root of 2 du. So we've gotten to a place where we can name our integral. So let's call this I1, or A as I usually like to do, and I2 or B. So pick both of them one by one. So this is where we'll hang this for now. So let's consider I1. So I1 is equal to the integral of 1 over u squared plus 1 over u squared minus root 2 du. Again, this is a sum of 2 squares. You remember a squared plus b squared is equal to a plus b all squared minus 2ab. So in this case, u squared plus 1 over u squared is equal to a, well, our a is u, our b is 1 over u minus 2 times u times 1 over u. So it means this can change into 1 over u plus 1 over u squared minus 2, because this cancels this, minus square root of 2 du. And we can actually write that to look like a sum of 2 squares. Yes. Okay, so because we have a negative sign, so we want to use the idea of completing the square method, where we have the ax squared plus bx plus c to be written as something ax plus h squared plus k squared. And for that to work, for us to be able to use the tangent identity, integral of 1 over u squared plus a squared is equal to du is 1 over a tan inverse of u over a. I want a situation where I can write this to be plus something. So it means I need to change my idea here a little bit. Let's tweak it a little bit. Okay. So we can, instead of, so a squared plus b squared is also the same thing as a minus b all squared plus 2ab, because a minus b all squared is a squared minus 2ab plus b squared. So when we add the 2ab, it cancels out. So we'll use, for me to be able to have plus 2, because if I use it here, so u squared plus 1 over u squared is u minus 1 over u all squared, then plus 2 times u times 1 over u. So it means I can replace this with 1 over u minus 1 over u all squared, then plus 2 minus square root of 2 du. So if we replace u minus 1 over u, like I said, this is my target, this is my motivation. I want to write it to look like something like this. So if we replace u minus 1 over u with v, so let v be equals to u minus 1 over u, then dv du is equal to 1 plus 1 over u squared du, 1 plus 1 over u squared du, and okay, so what will work here is the fact that okay, we can make it work. All right, so I don't want to hang around here. Another clever identity that we might need here is the fact that we can always split 1 as we like. So I can write, ordinarily 1 is equal to half plus half. So I can always make some funny arrangement for 1. So 1 is equal to half of, 1 plus a plus half of 1 minus a. Okay, because it's just like saying adding a over 2 and subtracting a over 2. So this is another manipulation that will be useful for us here. In fact, we need it right now. So because I can see u minus 1 over u and 1 plus 1 over u squared. So to be able to use that, I will split this 1 here. So this is going to be integral of, let's continue with our red column. So this is the integral of 1 into, or half into bracket. Which one do I want first? I want 1 plus 1 over z squared, then plus half of 1 minus 1 over z squared. So that will give us 1. Then the denominator remains the same. It's not z. Why do I keep writing z? So u, then u here. du. Then in the denominator, u minus 1 over u squared plus. Then this here, I can write it as the square root of 2 minus square root of 2 squared to be able to match what we need to do here. Okay, then this helps us to split it into two integrals again. So this is integral of 1 over 2. In fact, I can pull out the 1 over 2 of 1 plus 1 over u squared. So the idea of this comes from the fact that when we change, when we set v to be equal to u minus 1 over u, we can see that the derivative is 1 plus 1 over u squared. That is why I'm using that in my breaking down of decomposition of 1. So 1 can be 1 plus anything, 1 minus anything, halves of those. So, but I'm using 1 plus 1 over u squared and 1 minus 1 over u squared because of what we are going to see here. So this is 1 plus 1 over u squared over u minus 1 over u squared plus the square root of 2 minus square root of 2 squared du plus, okay, let me just put the 1 over 2 totally outside. Plus the integral of 1 minus 1 over u squared over the same thing, u minus 1 over u squared plus the square root of 2 minus square root of 2 squared du. Perfect. So we can now go back to our v substitution. So we have said v is equal to 1 plus 1 over u squared. I mean, u minus 1 over u. And the v is 1 plus 1 over u squared du. So if we take this as we have used I1 and I2. So let's take this as I1a and this as I1b. So come back to this. So I1a, using the v substitution, I1a is the integral of, so 1 plus 1 over u squared du is our dv over v squared plus square root of 2 minus square root of 2 squared. And that is exactly equal to, from here, our a, this is our a. So it will be 1 over square root of 2 minus square root of 2 tan inverse of v over square root of 2 minus square root of 2. So that is our I1a. What about our I1b? That one is a bit special because if we we cannot use the same substitution we used for I1a. So this works for I1a because the numerator is 1 plus 1 over u squared. So for the other one, we can use let me think about it for a minute. Okay, let me just write it out first. So I1b is equal to the integral of 1 minus 1 over u squared over u minus 1 over u all squared plus square root of 2 minus square root of 2 du. Okay, so what would be an appropriate v for us to use here? Okay, we have used v the other time. Let's use w here. So let w be equal, sorry about that, let w be equal to so what can I differentiate to give me 1 minus 1 over u squared? So let w be equals to u plus 1 over u. So because that will give us the w is equal to 1 minus 1 over u squared du. But what does the denominator, how does it transform to w? Okay. Let's think about it. U minus 1 over u all squared. Well, if w is u plus 1 over u, then okay, so what is u minus 1 over u squared? I want to write it in terms of w. So u minus 1 over u squared is u squared plus 1 over u all squared, then minus 2. Then this is the same thing as u, if we use the sum of two squares here, u plus 1 over u squared minus 2. So this minus 2, that will give us u plus 1 over u squared minus 4. Beautiful. And that is what we want, because this is w squared minus 4. So if w is u plus 1 over u, we found a way to rewrite that. So it means our I1b is integral of, so 1 minus 1 over u squared du, we've seen that to be equal to dw. So this is dw over w squared minus 4, then plus minus 4 plus okay, so let's remove this first, because if we do 4 plus 2 minus square root of 2, it gives us something interesting. So we have coming, so negative 4 plus 2, that is negative 2. And this is not plus, this is negative. Okay, that will give us a difference of 2 squares. So yeah, so this is dw over w squared minus 2 minus square root of 2. Yes. And this is the integral of dw over w squared minus 2 plus square root of 2. Okay. And we have this to be equal to the integral of dw over w squared minus the square root of 2 plus square root of 2 all squared. Whew. That's a lot. All right. So, and again, that brings us back to this guy. Oh, we did not state what the integral is. So anytime you have, okay, let's do it here. So if we are to find the integral of, therefore the integral of 1 over x squared minus y squared dx will be the integral of 1 over 2y 1 over x minus y minus 1 over x plus y. So that if I do it with the simple variables here, I don't have to do the heavy one with the ugly expressions we have down there. So this is equal to 1 over 2y integral of 1 or dx over x minus y minus integral of dx over x plus y. And that is 1 over 2y natural log of x minus y minus natural log of x plus y. Let me manage space, bring this here, bring this here, and this using the laws of logarithm, that is 1 over 2y natural log of x minus y over x plus y. So anytime we have the integral of 1 over a difference of 2 squared, to always give us this, the minus 1 will be in the top. So, and that is exactly what we are seeing here. This is like our x and this is like our y. So it means, therefore, I1b is equal to 1 over 2y. Our y here now is square root of 2 plus square root of 2 natural log of w minus square root of 2 plus square root of 2 over w plus square root of 2 plus square root of 2 plus c. So we have gotten I1a plus I1b. So it means that I1 in general, because this is I1 in general will be 1 over 2, because it is 1 over 2 times I1a plus I1b. So that will be I1a. Where is I1a? This guy. Let's copy. Let's take advantage of technology. Paste. Then plus I1b. Is it plus or minus? Plus I1b. This guy. Let's copy again. Paste. Beautiful. And then we need to bring back v and w to u. So you remember, so we recall that v was, where is it? V is u minus 1 over u, and w was u plus 1 over u. Therefore, I1 is 1 over 2, 1 over square root of 2 minus square root of 2, tan inverse of u minus 1 over u over square root of 2 minus square root of 2 plus 1 over 2 square root of 2 plus square root of 2 natural log of w is u plus, so we have u plus 1 over u minus square root of 2 plus square root of 2 all over w plus square root, u plus 1 over u plus square root of 2 plus square root of 2 plus c. So this is I1. Then I'm going to do a similar thing for I2. Where is I2? Okay, let's copy and paste. So I2, I want to consider I2 now. So again, we regurgitate the same ideas that we did the last time. So we know that u squared plus 1 over u squared is a sum of 2 squared. A squared plus b squared is, there are two things that we did. We could use a plus b all squared minus 2ab, or a minus b all squared plus 2ab. So if we use the same thing for u squared plus 1 over u squared, it can be equal to u plus 1 over u squared minus 2, because u times 1 over u is 1, or u minus 1 over u all squared plus 2. So which one should we use first? So we are going to use the same trick that we did the other time, but let's see what will necessitate that trick. So if we set v equals to u plus 1 over u, then the v will be equal to 1 minus 1 over u squared. And if we set w is u minus 1 over u, so this is du. The w is 1 plus 1 over u squared du. So I need to generate 1 minus 1 over u squared and 1 plus 1 over u squared in the numerator. The numerator here is 1. So I can rewrite 1 as 2 over 2. And 2 is the same thing as 1 minus 1 over u squared plus 1 plus 1 over u squared. So if we divide this by 2, we'll get 1. So it means that I can write I2. So that is the trick I should have. That's a better way to explain the trick in the first place. So this is 1 over 2 because of this. So I can say this is 1 over 2 times that. Integral of 1 minus 1 over u squared plus 1 plus 1 over u squared du over u squared plus 1 over u squared plus square root of 2. So I can now split this 1 over 2 into 1 minus 1 over u squared plus 1 over u squared plus square root of 2 du plus integral of 1 plus 1 over u squared plus 1 over u squared plus square root of 2 du. So the one where I have 1 minus u squared over, 1 minus 1 over u squared du in the numerator, I'm going to take as v. So maybe I should call this I2v. And this should be I2w. So to indicate that is what I want to take as the substitution. So I2v, I2w. So let's consider I2v. That's the integral of 1 minus 1 over u squared du over, so I can use this this factorization here. So u squared plus 1 over u squared is u plus 1 over u all squared minus 2. That is u plus 1 over u squared minus 2 plus square root of 2. That is my I2v. And if v is equal to u plus 1 over u, we have already seen that what the v du is. And so this will be, so maybe I should write it. The v is equal to 1 minus 1 over u squared du. So this integrand will become dv over v squared minus, this is, this is minus 2 minus square root of 2, like this. Then this inner one is square root of 2 minus square root of 2 squared. Yeah. So if we expand this, we're going to go back to that because the squares and square root will cancel out, and minus 2 plus square root of 2. We're good. So, and again, we've seen this. This is the integral of something over the difference of two squares, and we know this will generate the logarithm. If it was a plus, it will be arctan. If it was a difference of two squared, it will be logarithm. So this is going to be 1 over 2 of the square root of 2 minus square root of 2 natural log of v minus square root. Will there be a square root there? Yes. So did I miss a square root in the upper one? Oh, I did not miss it. Good. V minus square root of 2 minus square root of 2 over v plus square root of 2 plus square root of 2. Oh, it's also going to be minus plus c. And then it could be clever to bring the u back from here, but let's just go with, okay, let's bring the u back now. So this is 1 over 2 square root of 2 minus square root of 2 natural log of, so v is u plus 1 over u minus square root of 2 minus square root of 2 over v plus 1, or u plus 1 over u plus square root of 2 minus square root of 2 plus c. I should have been, changing the c's I'm getting. So maybe this is C1, maybe this one is C1b, C1a, and so on and so forth. That doesn't really matter. This is C2v. Eventually all of them will collapse into the big C. Then I2w, so let me squeeze it here. I2w is equal to the integral of 1 plus 1 over u squared du over, so since I'm using the w1 now, I'm going to use u minus 1 over u squared plus 2. U minus 1 over u squared, where is it? Plus 2 plus root 2, which is exactly the same thing. So if w is u minus 1 over u, the w is 1 plus 1 over u squared du. So we can rewrite I2w to be equal to we can write I2w to be equal to the integral of dw over, yes, let me check if I made a mistake. So if we make w to be u minus, oh, looks like I'm making a mistake. The original question is u squared plus 1 over u squared. Okay, I think we are still on the right track. U squared plus 1 over u squared here. And if I want that, I'll have u minus 1 over u squared. That will be u squared plus 1 over u squared plus 2. So if w is u minus 1 over u, I think they're good. All right, we are so good. I think we are good. So yes, so we have w squared plus the square root of 2 plus root 2 squared, and this is equal to, so because this is the integration, the tangent one, so this is going to be 1 over square root of 2 plus root 2 tan inverse of w over square root of 2 plus square root of 2 plus c2w. Okay, I think we nailed that. So I2v is 1 over 2 root 2. This is I2v here. 2 root 2 minus root 2 natural log of v minus square root of 2 minus root 2. Okay, that looks nice. So let's bring back the u for this one. So this is be 1 over square root of 2 plus square root of 2 tan inverse of what is w? W is u minus 1 over u. U minus 1 over u over square root of 2 plus square root of 2 plus c2w. Now the moment of truth. So what is I2? I2 is, so therefore I2 is 1 over 2 of I2v. Where is I2v? I2v is these guys. No, let me do that again so that it doesn't copy what we don't want. This, let me shrink it a little bit. Then plus I2w. Just copy this. Copy. Paste. Shrink it a little bit. Shift everything to the left a little bit. Plus C2. Yeah, so that is I2. Oh my God, we are at the end, because the end means we want to put in I1 and I2 together. So what is I? You remember that from the beginning we have I to be equal to, where is it? Square root of 2 of I1 plus I2. I hope I checked that correctly. Yeah. So in this case, what is I1? I1 is this this monstrosity. So we copy this, copy for I1. So I'm going to say, okay, spaced. So black. I is equal to square root of 2 times this guy plus the other guy, this one. Copy, paste. Now close the bracket. We are almost done. The question was given to us in X, And we recall that u is equal to 4th root of tan x. That is the only thing we need to plug in, and we'll be done. Should I do that? Can you do that for yourself? Okay, let's do it together. So we have I is equal to the square root of 2 outside, and so we're going to have 4 terms. 1, 2, 3, 4. Let's put the arctans together. So the arctans will be this one and this one. So both of them will be, so in the numerator we are going to have, let's open it, or should I leave let me leave the root 2 over 2 outside. Root 2 over 2, so this 2 has come out for both of them. Then we are going to have the arctan 1 over square root of 2 minus square root of 2. Then tan inverse of, so u is tan, 4th root of tan x. Let me write it that way. 4th root of tan x minus, so if u is this, 1 over u will be 1 over 4th root of tan x, which is the 4th root of 1 over tan x, which is the 4th root of cot x. So that we will have something that is not too ugly. 4th root of cot x over square root of 2 minus square root of 2. Then plus, is it plus? Did we lose a minus along the way? What is I2? Let's check carefully. Should it be a plus or a minus? Let's check carefully, because it should be symmetric, so you should have plus minus plus minus. So have we made a mistake? So if we do what was our, is it I1 plus I2 or I1 minus I2? Let's check quickly. Oh, it is I1 minus I2. Sorry. So I1 minus I2. So yes, we are back on track. So this is going to be minus, then the tan here is also 1 over square root of 2 plus square root of 2, tan inverse of the same thing. Let me just copy. Let me copy instead of rewriting it. Go back, copy, paste. But instead of negative in the denominator, is going to be positive. That's the only difference. Then plus, so plus this guy now. So that one is going to be a bit longer. So that would be 1 over 2. Okay, we have factored out we have not factored it out. 1 over 2 square root of 2 plus square root of 2. Then natural log of our u is 4th root of tan x plus fourth root of cot x minus square root of 2 plus root 2, then over the same thing, basically the same thing except for that plus and minus. Copy, paste. So this will be a plus over, then minus the last term. I can copy and paste, copy, paste. Okay, so but what is going to be different? Let me trace it. So this one should be minus, and this one should also be minus. So that is this guy. Then let's close the big bracket. Plus C. And with that, we've come to the end of this solution and the end of the video. Wow, what a long one. So the summary of the tricks that we use is we started with the u substitution, u equals to fourth root of tan x. It led us to this rational function as the integrand, u to the power of 4 plus 1 plus u to the power of 8. We could have gone by the way of trying to do a partial fraction decomposition from here, trying to decompose 1 plus u to the power of 8 into 4 quadratic expressions. But I think that method, I found out that method after a couple of days, that method will not be too nice, it will be too rough. Even this is not as rough as that will be. Then the trick that we have used here is to use the divide through by u to the power of 4, and it gave us some beautiful expressions in the denominator that eventually relied on completing the square, sum of two squares, and splitting it into appropriate mini integrand. So it's long. I think this is almost my longest solo video, and I hope you've learned one or two things along the way. And I'd like to hear from you, your comments, if there are any observation, perhaps if there is any mistake that I've made along the way. That is possible. So just put it down in the comment section. And if you like the video, you can press the like button and share it to your people. Enjoy yourself. I'll see you in the next video.